very good morning to all. I'm Swati Bhargava. My dissertation topic is Environmental Strategies for Workspaces in Hot, Dry Regions of India, Potential of Courtyards and Jalis. India has seen unprecedented growth in real estate and construction industry over the last few decades. It has emerged as the third largest startup base after the US and the UK. The recent trends in contemporary buildings have been influenced from the Western world and developed as glazed boxes with no consideration to local climate. This leads to high energy consumptions, dependence on air conditioning systems for most of the year, and creating an unhealthy and artificial working environment for the occupants. However, over hundreds of years, the vernacular precedents still stand as passive design solutions, where limited use of resources helped in achieving comfort conditions for occupants. The concern generates from the fact that in current practice, the traditional passive design strategies have been forgotten. Hence, there is a strong need to readapt these. The state government encourages the use of these features, especially for all the office buildings. However, they are merely used for aesthetic reasons rather than for their environmental pedigree. The studies are based in the city of Jaipur, in the state of Rajasthan in India. The coordinates are 26.9 north and 75.8 degrees east. The annual average temperature is 25 degrees. In summers, the temperature ranges between 23 to 45 degrees in a day. Solar radiation is high throughout the year, reaches up to 950 watt-hours per meter square. The dominant wind direction is from the southeast and at an annual average of 2 to 3 meters per second. Due to the proximity to the tropics, the sun angles are relatively higher. The west receives the highest amount of vertical radiation from April to September, while the south receives up to 200 watts per meter square for rest of the year. Precipitation is scarce. It rains around 12 days for 2 months of the year. So evidently, the climate suggests that the south and west need solar protection throughout the year. High diurnal variations of up to 19 degrees within a day could be useful for nighttime ventilation, and underground soil temperatures of average 25 degrees could be utilized for cooling effects by going deeper in the ground. The design brief: a workspace which could serve various business modules, creating interactive spaces for occupants to work in multi-functional zones, offering flexibility and adaptability. The design would primarily focus on occupant comfort in terms of creating a good environment with desired levels of thermal and visual comfort. The space types are classified as air-conditioned workspaces, naturally ventilated offices, and the shaded outdoor areas. The total built up for the project is 10,000 square meters. The site is located on the main road connecting the old city to the new development. The site area is 10,000 square meters. The context is scarcely populated. 80-meter thick vegetation separates the site from the noisy main road. The site offers views to the Aravalli Mountains to the north. The research work began with the literature review, where the key parameters pertaining to courtyards and jalis were looked at. Out of the built precedents, one of the studies was done for India Glycol office in Noida for the study of self-shaded courtyards and evaporative cooling. The next research work was conducted as a field work at Pearl Academy, Jaipur. Elaborate field work was carried out in the months of April and August. The concepts of solar protection through jali, use of step wells, and form optimization were analyzed. The temperature readings form basis of some of the assumptions which were incorporated in the design later. Similarly, another office building called 72 Screens was studied, and the jali was found to underperform in terms of daylighting. In this case, the last study was a traditional example of Hawa Mahal to understand the relation between the jali perforations and air and light permeability. The studies led my research to find focus on jalis and courtyards, coming to the hypothesis: jali is a device inspired from the tradition that combines attributes of solar transmittance, air permeability, thermal mass, visual and thermal control in a way that it achieves a better performance in comparison to a similar area of conventional glazing at a similar or lower cost. What would the courtyards do for me? Well, they would provide me with passive zones, shading, microclimate, and usable spaces for social interaction. On the basis of field work and the experiments held, environmental performance of the Jali screens was quantified. The graph shows the readings of 4 sizes of openings in the Jali and their relation with light and air permeability through them. As a starting point, a size of 80 by 80 mm was chosen. To calculate the depth for solar protection, the sun angles for south and west orientations were studied. In order to prevent the direct sun into the spaces, it was found that the required depth was 110 mm. Taking these parameters ahead, the daylighting was tested for the test plane at 750 mm height. 5 different scenarios were tested, from a fully glazed facade to varying window-to-wall ratios. As conclusion, a screen with 60% perforation openings was selected to find a passive zone of 6 meters. Similarly, studies for north and east orientation suggested that a passive zone of 6 meters would be provided with a wall-to-window ratio of 60% with vertical shadings 400 mm deep, spaced every 1 meter apart. These would provide adequate daylight as well as views to the scenic mountains. Further, for the thermal analysis, a series of simulations were done, starting from the base case of a fully glazed facade and further adding strategies like night ventilation, thermal mass, and we see that the improved case combines all the strategies. The difference in peak temperatures is about 12 degrees, and the cooling loads account to 30 kilowatt-hour per meter square as compared to 180 in the base case. After the initial set of research work and analytical work, the design development started. So the footprint offered by the site was taken as extrusion for 4 floors, up to 16 meters, as a D plan. In the next stage, a central courtyard was carved out after the 12-meter passive zone. As we see in the shadow analysis, the bigger courtyard was completely in the sun, and it has to be divided into smaller courtyards with aspect ratios of 1:1. The solar movement was studied to find some critical angles to achieve self-shading throughout the year. The comparative shadow analysis shows that with this configuration, the maximum shading could be achieved. Further, the voids were added in the facades to allow airflow and daylight. The shadow analysis was an integral part of the form development. The courtyard is a result of functional, aesthetic, and environmental reasons. The built form was then raised from ground, and underground levels were sunk to -3 meters to benefit from the ground temperatures. Moving to the plans, the plan offers flexible workspaces where occupants could move their places according to various activities as well as outdoor conditions. The air-conditioned and the naturally ventilated spaces could be coupled or decoupled by means of sliding glass panels as shown in the plan. The lower ground is primarily for recreational purposes. The voids act as breakout spaces on each floor. Looking at the sections, the evaporative cooling from the water bodies, jet fountains, shade, and landscape enable air to cool before it transcends into the courtyards. Further moving to the facade, the Jali design has been derived from the research work as discussed. Further, the horizontal openings were planned according to the eye levels of a standing and sitting positions for male and female occupants. When outdoor temperature rise above 35 degrees, the Jalis are equipped with drip system, which wets the Jalis and provides cooling at about 2.5 degrees lower than the outdoors. The Jali panels are 2.5 meters in length and 55 mm depth, with the opportunity of adaptive usage by sliding the glass panels over each other. The upper part As we see in the second photograph, the upper part remains fixed at all times. The lower part slides with intermediate positions where perforation percentage needs to be reduced according to the activity or the outdoor climatic conditions. The air exchanges per hour range between 1 air exchange to 10 air exchanges throughout these three options. The south and west orientations have the screen facades with adaptive usage. The north and east have windows with vertical elements offering views to the landscape extending to the mountains on the north side. The plan shows daylight autonomy for target level of 250 lux. The occupancy hours considered are from 9 a.m. to 6 p.m. The layout exhibits even distribution of light. The thermal performance for the hot period was analyzed with the application of the strategies discussed before. It can be seen that the naturally ventilated offices remain in comfort zone. However, due to high internal gains, the enclosed offices with the use of fans at 1.5 meters per second air velocity extend the comfort range. For the mild periods, the two zone exhibits similar temperatures up to 4 degrees lower than the outdoors. The temperature within the occupied hours remain in comfort, while the temperatures fall below comfort with 8 to 10 air exchanges at night when the building is unoccupied. To conclude, the design ensures 45% of the total area to be naturally ventilated. Out of the 55% area, the cooling loads considerably lower down to 30 kilowatt hours per meter square as compared to the Indian benchmark of 140 kilowatt hour per meter square. To reiterate the hypothesis, the cost analysis was carried out. The jalis and facade are made from the locally available clay ceramic bricks. The strategies used in the proposal not only save the initial cost of the project by about 25%, but also contribute to long-term energy savings of up to 83%, providing the users with adaptive opportunities. The two sections illustrate the environmental performance of various spaces on a hot day in morning and afternoon hours. The UTCI and MPET values demonstrate the user comfort. The occupants use the breakout spaces for individual as well as collective working. The landscape and airflow make the occupant feel at 26 degrees when the outdoors are 34.5 degrees, giving a neutral feeling. While in the mild periods, the views to outdoors would encourage more occupants to occupy the spaces. In the courtyards, during the mild periods, the ambient air temperature inside creates its own microclimate to make the occupants feel slightly cool. During the hot period, the jalis close. The building isolates itself from the harsh outdoor climatic conditions, relying on its own microclimate. During the mild period, jali screens and the glass partitions open and allow natural ventilation throughout the two zones, thus eliminating the need for air conditioning. In conclusion, this dissertation would provide some useful starting points or guidelines to the government organizations and developers to restore the respected traditional elements like courtyards and jali by taking advantage of their environmental pedigree and not just as decorative elements. This small step would go a long way ahead in transforming the energy scenario and creating climate-responsive, healthy, and economical occupant-centered workspaces in the hot, dry regions of India. Thank you all for your attention.
Thank you, Swati. Who would like to start? Nick, maybe?
Oh, thank you very much for that very interesting presentation. It's very nice to see how you're responding so creatively to all the environmental challenges. I've just got a couple of questions. I was very interested in your systematic analysis of the jali and revisiting it as if it may have more functions than we may think. In the simulation, I'm not too familiar with your simulation software. Does it simulate reflected shortwave radiation? So I'll give you two questions. Does it affect in other words, what reflectance do you model, and does this influence the daylighting? And the second thing is, does it influence the transfer of heat from the jali to the ventilation air?
For the modeling in the software, I tested 3 different jalis as indicated in the graph, where solar transmittance changed from 0.2 to 0.5. And the airflow was tested as physical models, which was not presented today. So therein I derived a relation between the airflow and the solar transmittance, and then went ahead with the 60% perforation ratio for the jalis.
Okay, right, thank you. The only thing I'd say is that the idea of a shading device also interacting with ventilation and having thermal storage is very interesting, but it carries penalties because, of course, if the heat is retained in the jali, that will be transferred to the ventilating air. Now, when you use the canopy of a tree to shade, the air that ventilates the tree isn't the same air that you use to ventilate the building. So I'm just asking you those questions because I'm wondering whether the software does take that into account. But I think you've given an answer, so I'll leave you to that.
Thank you.
Congratulations, I think.
Thank you.
I think it's a very nice project, and I think you managed to integrate all the different aspects and the right aspects. I think the right ingredients for a project in India. I like the way you integrated the transitional spaces, the jali, the natural ventilation, evaporative cooling. So you think you seem to have the right ingredients. What is a bit more, I have more questions about the way you have simulated it, because I mean, I know from experience that this is difficult because I've done a project in India recently, and we were doing jalis,
Yes.
which is a very tricky one. And so one of the questions I have is, you mentioned evaporative cooling, and you have some water bodies at the ground floor,
Yes.
plus you're also using, you're wetting the jalis. But did you, when you simulated the thermal model of the building, did you use evaporative cooling all the year round, just in certain seasons, or how do you break the simulation in 3 seasons, or how do you do
The
that?
simulations are not done with evaporative cooling. For
Okay.
the evaporative cooling, I went back to the same city and I conducted physical experiments at different times of the day with different outdoor conditions. And on the basis of these calculations, I predicted the scenario when the temperature goes above 35, then how do the evaporative cooling takes place. But for the simulation softwares is without the evaporative cooling.
So you're not taking benefit of that in your simulations?
In the simulations, no.
So, but potentially could be your energy results could
Yes.
be better. And the other thing is, you mentioned that you would wet the jali. What is the material they're using in your
It's
jali?
clay ceramic bricks, which is a very prevalent material over there. It's a locally manufactured
It's porous and
material,
will absorb.
which has the properties of thermal mass, and it's a very famous technique to wet these and then take advantage of the evaporative cooling.
Yeah. Then for daylight, I think you showed some results of a UDI, and I think it's the same question, I think, because you have the facade that sometimes it's open, sometimes it's closed. So did you do a UDI for the whole year? And if you did
It's for the closed scenario.
all right.
Yes.
But is the closed scenario the whole year or for a specific season, or how do you?
For the modeling, I consider it closed.
Okay.
Yes.
But I mean, ideally, you have to reflect those changes. I know it's technically
Yeah.
quite complicated and very time-consuming, but I think you should explain it in your text. Like saying, I mean, I'm not
Right.
fully representing how the facade would perform, because this dynamic performance is very difficult to demonstrate. But just for you to
Right.
know.
I get it.
The last question I have is, thermal comfort, you showed some images of some people in your terraces, and they were exposed to the sun. I think this one, and I think the previous one. Temperature 33 degrees. The wind is 1.7 meters per second, which means that probably if you didn't have that wind, I'm not sure if these people would feel neutral. I don't know if you're taking into account solar radiation in this thermal comfort analysis, because
For these calculations, the wind, I took the speeds from the wind analysis where the air is coming through the courtyards, getting cooled by vegetation and use of water. And yes, it is the air velocity which makes the occupant feel comfortable. That's why the role of voids comes in.
Okay, but just, okay, I agree, and I think at least you know that, but I think it's a bit difficult to predict how this wind is going to perform, and you may have some places where you don't have this wind that you're expecting, but at least you have the option of moving in and out and choosing the place where you are, because you have different locations in your building. It gives you a lot of flexibility, so I think overall your design, I think, gives you options to be comfortable.
Thank you.
And somehow the options sort of bring you to much more, I think, that could be done here. I thought this was really, really cool. And I'm with Nick. I didn't know that you could do so many things with such a relatively simple device as the alley made out of the earth, you know, that the building is built on. It's really quite clever. When you talked about, so a couple of things. I think you really did well in looking at the building from a plan perspective and from a sectional perspective at the same time. And you were finding, of course, because the wind comes in, the sun comes in, everything is quite directional, that making spaces and making comfort in this huge variety of spaces is really what you were doing here. And you did a lot of analysis that helps it, but actually architecturally, you're trying to make places for a variety of conditions, different times of the year, different conditions, but also potentially different functions. So what it makes me think is, once this building is there, how do you use it, you know? And you might also, I'd be very tempted to, if a building like this were built, to pack it jam full of sensors, and to measure what's going on and how it works. And I wonder whether there is a next step where you connect the learning at the time that it happens to the use of the building, so you get a reflection, and people will have a better informed choice to make of where in the building they want to be, you know. And then I think my last point is that somehow I've thought for a while that you should have some sort of reason to make this big square box and orient it quite like that, which you didn't discuss. On the one hand, it doesn't really matter. It's almost a context that you're given, and you try to make, and you have made the best out of it that you possibly can. But I wonder actually whether that is the first step to take. Is the site like this? Why is the site like this? Why is it like north-south like that? And you talked a bit about the views, and the views are cool. They're important. But I think the architectural choices you need to discuss that a little bit. It maybe not totally extensively, but I think it's interesting just to have an opinion about where people are in the project, and how the sectional and plan approach that are so rich and so well detailed, how they relate to the use of the building. I thought it was great. Thanks.
Thank you.
Thank you, Swati. It was a very clear and comprehensive presentation, and a lot of progress since last time. I have mainly two things to highlight. One is in following what Ron just said. I think that you should not forget in your dissertation, and when you were explaining the shaping of your form, because you didn't bring this in this presentation, although we know that the site is free of surrounding buildings.
Yes.
But I think this should be clearer when you're explaining the development of your shape. There is a landscape, there is a mountain, there are trees.
Yes.
And we don't know, about, you're giving a lot of importance to the views and to protect from wind and or allow the wind. So all these, it needs to be clear that the context
Yes.
when you're developing your shape, yeah?
Yes.
Okay. And the other thing I think it would be worthwhile including is that you gave quantification of the cooling loads, and you even mentioned comparison with conventional buildings.
Yes.
But you also studied more modern buildings, and I think it would be worthwhile also providing a comparison to those benchmarks or those existing.
Yes.
Maybe you have it in your dissertation, but you didn't mention them here, so.
These are the studies I conducted.
Yes.
So the design proposal is at 30, and since the PEARL is lower than the design proposal, but it's an institution, it's not office buildings, so the internal gains were lesser. And the other two case studies are at 60 and 80.
Thank you.
Well, thank you for your presentation. I think it was very clear, and these fantastic graphics allow us to follow and to be convinced. And it was so convincing that perhaps at some point one may think, if it performs so well, even the outdoor space, why do you need air conditioning at all in the office? And we know the climate, we know it's a hard climate, but if we only look at your results, even the naturally ventilated space seems to perform very similar to the air-conditioned space. And I think perhaps you should, in the book, drive us into a little, in greater detail throughout the process to know what are the key factors, the driving forces shaping this performance. That is something that, well, because it's a brief presentation, it's obviously not possible to include everything. But so I have so many questions about the every slide that opens so many. So how is this possible? How is this performance being produced? That I hope to see that in the book.
I have explanations in the
Yeah.
book, yes.
I'm especially interested on something that is new to me, that is the system by which the jelly gets wet. So I'm hoping also to know a little more about that. How do you expect it to perform? What do you expect it to produce? Because, as you said, it's not included in the simulations.
Yes.
So, and how do you think it may work? As for the outdoor space and for the wind, you can also, well, at some point, perhaps the wind, when it's not there naturally, it could be there by some fans on ventilators. So that's not a problem. But overall, congratulations.
Thank you.
Well, I think you have shown that this was a very good research project in the sense of coming up with certain hypotheses about certain features that come from traditional architecture and then taking those through the rounds of research and showing that their worth as applicable to contemporary buildings and then going through the whole process of refining them in the design. So I think it's a very worthwhile exercise altogether, but both as a learning process and also as a design agenda. And I think we come to the end of the project, and then you're showing rightly that the initial hypothesis about the jali appears to be corroborated, that it does deliver performance-wise and cost-wise, which is very nice. However, I think you have already heard some questions about the confidence that one can apply to the performance that the Jali might deliver. And I think this is impossible to ascertain by simulation, although there are so many things where simulation is actually the arbiter of performance difference. Here, it's almost impossible, and the proof, as I think Ron was suggesting, is to be able to build and measure. Of course, perhaps there is the difficulty of anyone giving you a full building to do in order to find out whether it's going to work as well as you think it will be. However, it should be possible, I think, to do a sort of test cell, to have a comparison where a variable sort of Jali-like structure can be next to a more conventional, and that measurements can be taken. I'm pretty sure that you could do that at low cost or very little cost. The other thing, sort of inspired from Ron's comment, I think Ron was questioning whether orientation was an issue or a friend in any case, in the sense that you were taking orientation as a friend because, well, the site allows a choice of orientation, and so you choose the sort of orientations and axes for the building that you think provide a better solar environment. But at the same time, the Jali and the other strategies that you have, including the proportions of the courtyard, allow you to protect from the sun come what may. And therefore, in a way, and this is how I read Ron's comment, perhaps you have a solution to whatever the orientation. So whatever the orientation, the combination of Jalis and the other devices that you have will allow you to. However, it won't be always the same, and I think this is illustrated by the fact that on your building as is now, each orientation is different because it responds to essentially the solar geometry. And therefore, if you had a different situation on the site, then different orientations and the elevations would rearrange themselves to provide a good solution for those. So overall, a very good project. Thank you very much. Well done.
Thank you.